Let's get right into it. Number 10. There are real places in space more hellish than anything in fiction. In 2018, astronomers confirmed the full picture of a planet called K2-141b, a world roughly 200 light-years away that will make every fictional hellscape you have ever seen feel like a mild inconvenience. On the day side of K2-141b, which permanently faces its star and never rotates away, the temperature reaches almost 3,000 degrees Celsius. That is hot enough to vaporize rock, not melt it, vaporize it. The surface is covered in a global ocean, not water, not lava, but liquid rock, and above it hangs an atmosphere made entirely of vaporized minerals, sodium, silicon monoxide, silicon dioxide, all of them gaseous, all of them cycling through a planet-wide weather system unlike anything in our solar system. The winds in this rock vapor atmosphere reach speeds of over 3,000 miles per hour, carrying vaporized stone from the day side toward the night side, where temperatures drop enough for it to condense and fall. It rains rocks on K2-141b, actual rocks, precipitating out of a mineral atmosphere, landing on a surface that is itself made of molten stone. Then they slowly flow back toward the dayside ocean to be vaporized again. A permanent, endless cycle of rock evaporating, raining, and melting on a planet that has been doing this every single day for billions of years. No science fiction writer has ever described a world this specific in its horror, because the human imagination tends toward drama. The universe tends toward physics, and the physics of K2-141b makes the most extreme fictional hell ever written look like it was conceived by someone who had simply not tried hard enough. Number 9. Some objects in the universe shouldn't exist, but do. In 2012, NASA's Kepler Space Telescope confirmed 3 planets orbiting a star about 2,600 light-years away. And when astronomers calculated what they were made of, they had to check the numbers more than once because the answer made no physical sense. The planets, cataloged as Kepler 51b, 51c, and 51d, are roughly the size of Jupiter. Saturn-sized, some of them even larger, but their mass is tiny. Kepler 51b, one of the most extreme cases ever measured, is about 500 times less dense than Jupiter. To put that in terms you can actually picture, if you could somehow fill a bathtub with material from Kepler 51b, it would be lighter than the air in the room around you. NASA researchers, when describing these planets publicly, used the phrase cotton candy, not metaphorically, as a genuine density comparison. These are Jupiter-sized worlds made of something approximately as substantial as spun sugar. The problem is they should not be able to exist. At their size, gravity should have compressed their material long ago. Their host star's radiation should have stripped their outer layers clean. Every model we have for how planets form and hold together predicts that objects like these either never form in the first place or collapse and compress into something denser within a relatively short window of cosmic time. Kepler 51b is estimated to be only a few 100 million years old, young by planetary standards, which is the leading explanation for why it hasn't compressed yet. It is essentially a planet still in the process of becoming something denser, a temporary object, a cosmic mistake that physics is slowly in the process of correcting. The universe, apparently, does build things that break its own rules. It just doesn't let them stay that way forever. Number 8. There are regions of space where reality starts breaking down. Sometime in the 1970s, physicists working through the mathematics of black holes confirmed the existence of something called the photon sphere, a real physical region surrounding every black hole where the gravitational pull reaches a precise point, strong enough to trap light itself into a circular orbit, not pull it in, not let it escape, hold it in a perfect loop, endlessly circling. And what happens to a person standing in that region, if they could somehow survive there, is where physics starts to sound less like science and more like a nightmare. At the photon sphere, light traveling outward from the back of your head would curve around the black hole and come back to your face from in front of you. You could look straight ahead and see the back of your own head orbiting toward you. Your entire field of vision would be a hall of mirrors made of space-time itself, with copies of your own body arriving from every direction simultaneously, each image slightly delayed, showing you moments from your own past. The sky above you would show the entire universe compressed into a single bright ring. Every star, every galaxy, every photon that has ever passed through that orbit, stacked on top of each other in one glowing band. We confirmed this is real. The Event Horizon Telescope captured the first direct image of a black hole's photon sphere in 2019, when it photographed the glowing ring of light orbiting the black hole at the center of galaxy M87, 55 million light-years away. That image, the blurry orange ring that briefly appeared on every news site in the world, is not an artist's impression. It is a photograph of a place where light goes in circles and the normal rules of what you can see and from where and when have completely stopped functioning. The universe contains locations where the most basic assumptions about reality, that light travels in straight lines, that cause precedes effect, that you cannot see yourself from the outside, are simply not true. We have the photograph to prove it. Number 7. There may be alien megastructures hiding in plain sight. In 2015, astronomers pointed the Kepler Space Telescope at a perfectly ordinary star roughly 1,400 light-years away. What they found was anything but ordinary, and to this day, nobody has a clean explanation for it. The star, officially cataloged as KIC 8462852, but quickly nicknamed Tabby's star after researcher Tabitha Boyajian, was dimming. Stars dim all the time. Planets passing in front of them do exactly that. But this was different. The dimming was massive, irregular, and shaped in ways that no planet, no moon, no natural object should be able to create. At one point, the star lost 22% of its brightness. For comparison, a planet the size of Jupiter only blocks about 1%. Whatever was in front of Tabby's star was enormous, and it wasn't round. Scientists ran through every explanation they had: dust clouds, swarms of comets, instrument errors. One by one, the natural explanations either fell apart or barely held together. And then someone said what everyone else was quietly thinking. What if it's a structure? The concept is called a Dyson sphere, a megastructure built around an entire star to harvest its energy. Physicist Freeman Dyson first described it in 1960 as a thought experiment. If a civilization keeps growing, eventually they run out of energy on their home planet. The logical next step is to consume the energy of their sun directly. Wrap it, farm it, use every photon it produces. Here's what makes this deeply unsettling. We wouldn't build something like that unless we desperately needed to. Any civilization constructing a Dyson sphere has moved so far beyond us that comparing ourselves to them is like comparing a campfire to a nuclear reactor. They aren't building cities anymore. They are consuming stars. Tabby's star isn't alone. Since 2015, astronomers have flagged dozens of other stars showing irregular, unexplained dimming that current models can't fully account for. The leading explanation for each of them is still dust, but most likely is not the same as certain. Think about that for a moment. We've been staring at the night sky for thousands of years. We've built incredible machines to see further and deeper than ever before. And somewhere in all of that data, there may already be evidence of someone else's engineering project hiding in plain sight, and we keep finding reasons to look away. Number 6. Earth could be wiped out by something we never saw coming. On the morning of February 15, 2013, the residents of Chelyabinsk, Russia stepped outside into a clear winter day. Then the sky caught fire. A rock roughly the size of a 6-story building entered Earth's atmosphere at nearly 4,000 miles per hour, completely undetected. No telescope had seen it coming. No early warning system had triggered. No alert had been issued anywhere on Earth. It exploded in the upper atmosphere with a force 30 times greater than the atomic bomb dropped on Hiroshima. The shockwave shattered windows across 6 cities and injured over 1,500 people. If it had held together a few seconds longer before breaking apart, a single Russian city might have ceased to exist. What makes this event truly chilling is not the explosion itself, it's the reason no one saw it. The Chelyabinsk object arrived from the direction of the sun. It was our own star that blinded us to it. On that exact same day, while the Chelyabinsk rock was silently closing in, astronomers were tracking a completely different asteroid passing Earth at a safe distance. We were watching the wrong rock. We are still watching the wrong rocks. This is not ancient history. In 1994, astronomers observed Comet Shoemaker-Levy 9 slam into Jupiter in a series of impacts that left scars larger than the entire planet Earth. Those scars took weeks to fade. The comet had been orbiting Jupiter unseen for years before anyone noticed it. We spotted it less than 2 years before impact. Our current planetary defense networks do a reasonable job tracking the largest, most predictable objects. But long-period comets, massive icy bodies from the outermost edges of the solar system, some completing a single orbit over tens of thousands of years, can appear with weeks of warning, sometimes less. They travel so fast and from such remote, unmonitored regions of space that by the time we detect them, there may be nothing we could do. The universe does not send warnings. It does not care whether you were prepared. And somewhere out there, right now, something may already be on its way, and the sky above you gives no indication of that whatsoever. Number 5. Earth can be destroyed without being hit by anything. Most people assume that to destroy Earth, something would have to physically strike it. A massive asteroid, a rogue planet, an impact you could see coming from a distance. But there is a confirmed, scientifically accepted scenario in which every living thing on Earth's surface is annihilated without anything making contact at all. No collision, no warning, just light, arriving at the speed of light itself. In 1967, U.S. military satellites designed to detect nuclear explosions in space started picking up strange signals, enormous bursts of gamma radiation from far outside our solar system. Scientists initially thought the equipment was broken. It wasn't. These were gamma-ray bursts, or GRBs, and they remain the single most violent explosions ever detected in the universe since the Big Bang itself. A typical GRB releases more energy in a few seconds than our sun will produce across its entire 10 billion-year lifetime. Think about that sentence again. A few seconds, 10 billion years. These events are so extreme that they briefly outshine the rest of the visible universe combined. Here's what one pointed directly at Earth from within our galaxy would do to us. The gamma radiation would begin destroying our ozone layer before we even had time to react. Within hours, the protective shield that filters the sun's ultraviolet radiation, the layer that makes complex life possible on Earth, would be gone. The surface would be exposed to levels of radiation that nothing could survive for long. Not deep ocean creatures. Not microbes buried in rock. Nothing that needs the surface to eventually survive. We detect roughly 1 GRB per day, somewhere in the universe. They appear completely random. There is no schedule. There is no pattern. Scientists estimate that a burst occurring within 6,000 light-years of Earth, aimed in our direction, would be sufficient to trigger a mass extinction. Some researchers now believe this already happened to us. The Ordovician extinction, roughly 450 million years ago, wiped out 85% of all marine species on Earth. The cause has never been fully explained. One of the leading theories is a gamma ray burst from a distant star, something that happened billions of miles away, ending most life on this planet without touching a single grain of sand. The universe has a long-range weapon. It has used it before, and we would have about as much warning the next time as the creatures that didn't survive the last. Number 4. Our galaxy is not a permanent safe place. We tend to think of the Milky Way as home, something stable, something fixed, something that has always been there and always will be. But in the late 1970s, astronomers started noticing something they couldn't explain, something that has quietly unsettled the scientific community ever since. Galaxies weren't moving the way they should be. When researchers mapped the motion of galaxy clusters, they discovered something impossible by the standard model. Hundreds of thousands of galaxies, spread across an enormous region of space, were all drifting in the same direction, being pulled toward a single point. And that point was dragging our galaxy along with everything else at roughly 14 million miles per hour. They named it the Great Attractor. This gravitational anomaly sits approximately 150 million light-years away, hiding behind a region of space called the Zone of Avoidance, a part of the sky completely obscured by the dust and gas of our own galaxy's disk. We cannot see it directly. We know it exists only because of its gravitational pull, the same way you'd know a drain exists in a bathtub by watching everything spiral toward it. Something massive is pulling our entire galaxy toward a destination we cannot observe. And that isn't the only unsettling thing happening to the Milky Way right now. As you watch this, our galaxy is actively tearing apart and absorbing a smaller galaxy called the Sagittarius Dwarf. Stars from that dying galaxy are already passing through our region of space, refugees from a cosmic body being digested out of existence. If any of those stars ever hosted life, that life is gone, not destroyed in an explosion, erased, absorbed, dissolved into a galaxy that bears no resemblance to the one they formed in. In approximately 4.5 billion years, the Milky Way will collide with the Andromeda Galaxy. Our night sky will be unrecognizable. Stars will be hurled into the void between galaxies. Solar systems will be torn apart. And the galaxy we call home, the spiral shape we see in textbooks, the structure our civilization has never known anything outside of, will stop existing as a coherent object. The universe does not offer permanent addresses. It never has. Number 3. We could be living in a brief, safe window. Here is a thought that tends to stay with people long after they first encounter it. If you stretched the entire 13.8 billion year history of the universe across a single calendar year, complex life on Earth would appear in the final few days of December. We think of ourselves as a young species on a young planet, but in cosmic terms, we might not be early at all. We might be running behind, arriving into a window of safety that is already partially closed without knowing how much time is left. In the early universe, conditions were catastrophically hostile to complex biology. Radiation levels were extreme. Gamma-ray bursts occurred far more frequently. Star formation was violent and chaotic. Billions of years had to pass before things calmed down enough for a planet like Earth to exist, and then billions more years before life on that planet could develop into something that could ask questions about the universe. But there is growing evidence that this window has limits on both ends. Astrophysicists describe something called the galactic habitable zone, the idea that only certain regions of certain galaxies at certain points in time can support complex life. Too close to a galactic center, lethal radiation. Too far out, not enough heavy elements to build rocky planets. Too early in the universe's history, too chaotic and violent. Too late, stars are dying faster than they're being born, and the raw materials for biology are running low. Earth exists in a remarkably well-positioned moment in space and time, and that positioning may not be permanent. This connects directly to one of the most disturbing ideas in modern science, the Fermi paradox. In 1950, physicist Enrico Fermi sat down at lunch and asked a deceptively simple question. If intelligent life is statistically likely across billions of years and hundreds of billions of star systems, where is everybody? One answer, the one scientists least want to be correct, is called the Great Filter. The theory suggests that some barrier exists in the development of civilizations that almost nothing survives. If that barrier is behind us, we are extraordinarily lucky. If it is ahead of us, then something is waiting for every civilization that reaches exactly the level of development we are at right now. The silence of the universe may not be a mystery waiting to be solved. It may be a warning we haven't yet learned to read. Number 2. Broadcasting our existence might be a terrible idea. On November 16, 1974, scientists at the Arecibo Observatory in Puerto Rico aimed the world's most powerful radio telescope at a cluster of 300,000 stars and sent a message into deep space. That message contained our location in the solar system, a diagram of our DNA, what a human being looks like, and the number of people alive on Earth at the time. It was designed to say, as clearly as possible, we are here, we are intelligent, and we are not alone. Some of the greatest scientific minds of the century quietly considered it a catastrophic mistake. Stephen Hawking warned about this publicly and repeatedly in the years before his death. He compared making contact with an advanced alien civilization to early Native Americans encountering European explorers, and pointed out that the encounter did not go well for the side that was less technologically developed, not because the Europeans were necessarily evil, simply because the power difference was so large that the less advanced group had almost no ability to protect itself or negotiate on equal terms. Carl Sagan, one of the most passionate advocates in history for the search for extraterrestrial life, urged serious caution about broadcasting our location before we had any idea what might be listening. Here's why that caution makes sense. Any civilization capable of receiving our transmissions and traveling to us would be so far beyond us technologically that the comparison almost defies description. The gap would be similar to the gap between us and ants. And crucially, we don't ask ants for permission before we build on their habitat. We don't feel guilty about it. They simply aren't relevant to the decision being made. The meaty debate, messaging extraterrestrial intelligence, is still an active argument among scientists, with serious researchers on both sides. But here is the part we can no longer argue about. It is already too late to stay quiet. Earth has been leaking radio signals into space since the early 1900s. A growing sphere of electromagnetic emissions now extends more than 100 light-years outward from our planet in every direction, announcing our existence to every star system within that radius. We cannot take it back. We cannot turn it off. If something within that sphere is listening, it already knows we're here. We made the choice. We just didn't realize we were making it. Number 1. The universe may be full of dead civilizations. This is the one that tends to land differently than the others. Not because it threatens you personally, not because it involves a specific catastrophe aimed at Earth, but because of what it implies about the nature of intelligence itself and about where we might be heading without realizing it. We have been scanning the sky across every frequency of the electromagnetic spectrum for decades. We have sent and received signals. We have built instruments sensitive enough to detect the faint chemical signatures of atmospheres on planets orbiting distant stars, and we have found nothing. No response, no pattern, no signal that holds up under scrutiny. One interpretation of this silence is more disturbing than any other. Maybe they were there. Maybe the universe has hosted thousands of civilizations, some of them billions of years old, some of them capable of feats we cannot conceive of. And maybe they are gone, not because they were destroyed by asteroids or gamma-ray bursts, but because something in the nature of civilization itself, something that emerges once a species reaches a certain level of technological power, tends to end it. In 2020, a study published in the Astrophysical Journal estimated that our galaxy alone may have hosted 36 communicating civilizations over its lifetime. The paper's authors noted that the majority of them are almost certainly already extinct, and that the average distance between us and the nearest one is approximately 17,000 light-years. Even if one of them is trying to reach us right now, the message may be traveling toward a planet that won't exist by the time it arrives. The universe may not be empty. It may be full of ruins, signals that went silent thousands of years ago, planets where something once built cities, and where something then happened that left no survivors to explain it. We are on that same timeline. Every civilization in history has been. The only question, the one we don't have an answer to, is where exactly on that timeline we are standing right now, and whether the silence we hear when we listen to the stars is the universe's natural state or the sound of everyone who came before us, not making it. That's it for today. Subscribe for more.